All right, welcome back to our cloud computing course. For Lecture 10, we're going to take everything we've learned about XML and use it to understand the real architectural backbone of the cloud. We're talking about web services and the big idea behind them, service-oriented architecture.
So, here's our game plan for today. We'll kick things off by figuring out what a web service actually is. Then we'll zoom out to see the design philosophy it lives in, which is SOA. After that, we'll get into the nitty-gritty with the core protocols, see how they all play together in the publish, find, bind workflow, and then, most importantly, we'll tie it all back to why this is the engine behind pretty much everything as a service in the cloud.
Okay, let's dive right in. Before we go any further, we have to get a super clear, solid definition of what we mean when we say web service.
Now that's a mouthful, I know, but the absolute key thing to get here is this. A web service is built for machines to talk to other machines. That's it. It's a piece of software, it has a web address, and it uses XML to chat with other software over the internet. No humans required.
This right here shows the huge mental shift we're talking about. The web you use every day, that's HTML, designed to make things look pretty for people. But web services, they use XML, which is all about structuring data for applications. We're moving away from just presenting information to actually exchanging raw, structured data. It's a fundamental change. So these web services don't just exist out in the wild. They're part of a bigger design philosophy called service-oriented architecture, or SOA. And SOA provides the rules of the road for how they all interact.
In the world of SOA, you've basically got three main players. First, you have the service provider. That's the one who builds and runs the service. Then you have the service requester, which is the app that needs to use the service. And right in the middle, you have the service broker. Think of the broker as a matchmaker or a directory that helps the requester find the right provider.
Okay, now let's pop the hood and see the actual technology that makes all this communication possible. Let's talk about the web services protocol stack.
This is a beautiful way to see how it's all layered. At the very bottom, you've got XML. That's the data itself. One layer up, you've got SOAP, which is the messaging system. Then you've got WSDL, which describes what the service can do, kind of like a user manual. And at the top, UDDI, which helps you find the service in the first place. And notice the common thread? It's all built on XML.
Let's dig into SOAP for a second. The easiest way to think about it is as a standardized envelope for our XML messages. It defines the to, from, and what's inside structure. And because it's platform neutral and usually just piggybacks on HTTP, the same protocol your web browser uses, it slips right through firewalls. That was a huge deal compared to older, more complex systems. Okay, so if SOAP is the envelope, WSDL is the instruction manual that comes inside it. It's a machine-readable contract written in XML that tells any potential user exactly what the service does, what kind of data it needs, and how to properly connect to it. No guesswork.
And that brings us to UDDI. UDDI solves the big question. Okay, this cool service exists somewhere, but how do I find it? It's basically a global public directory where service providers can list what they offer so that service requesters can search and find exactly what they need.
This analogy is absolutely perfect. Seriously. Before Google, if you needed a plumber, you grabbed the yellow pages. In the SOA world, if your application needs, say, a weather forecasting service, it goes and looks it up in a UDDI registry. Same idea. All right, so we've met all the players and we've seen all the technologies. Let's put it all together now and see how this actually works in practice. This is the dynamic workflow that makes SOA so powerful.
It really comes down to this super elegant three-step process. First, the provider publishes its service manual, that WSDL file, to the UDDI directory. Second, a requester comes along and queries that directory to find a service that meets its needs. And third, once it has the WSDL, the requester can bind directly to the provider and start that conversation using SOAP messages. Publish, find, bind. That's the loop.
So, we've gone through a lot of architecture, a lot of three-letter acronyms. But what does this have to do with cloud computing? Why is this so incredibly important?
And here it is. This is the big payoff. The entire anything as a service model, whether it's infrastructure, platform, or software as a service, it's all built on these exact ideas. The cloud works because it's a massive collection of independent services that can find and talk to each other using standard protocols. Modern cloud platforms are basically SOA on a global, epic scale.
And that's really the thought I want to leave you with. This isn't just academic. This is a blueprint for creation.
Once you understand that every cloud service for storage, for databases, for AI is just a building block, you realize you can combine them in new ways. You can snap them together like digital Legos to build incredibly powerful applications that no single person could build from scratch. And that is the real power of the cloud.